With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let's start the question. The question says that find the equivalent resistance of the circuit of the previous problem between the ends of an edge such as A and B in figure. So we need to find the equivalent resistance between these 2 points, between A and B. Now if we see carefully, this point H is, if you go from A, it is, you have to move across the edge, and from B it is along the body diagonal. This is body diagonal. And similarly, if you see point D, if you go from A to B, you have to move along the edge, and from the B it is along the body diagonal. That means D and H are at same potential. From A to D and A to H, if you go, you have to move across the edge, and from B you have to go along the phase diagonal. FD means phase diagonal. Similarly, if you see here point E, if you go from A, you have to move along the phase diagonal, and from B you have to move along the edge. Similarly, point C, if you go from A, you have to move along the phase diagonal, and from B you have to move along the edge. That means C and E are also at same potential. That means from A, if you go to C or if you go to E, you have to move along the phase diagonal, and from B you have to move along the edge. That means these two are at same potential. C and E are at same potential, and D and H are at same potential. Now if you draw the equivalent circuit diagram, it will be like this. Let us say this is point A, and here it is point B. This is point D and H, and this is point C and E. Now if we see carefully, between A and D one resistance is there, so let us draw it. And between A to H one more resistance is there, let us draw that one also. Now between B to C there is one resistance, let us draw it. And now between B to E there is one more resistance, let us draw that one also. Now between D to C there is one resistance, so let us draw it. And between H to E there is one more resistance, let us draw that one also. Now from D and G, if we go, there is one resistance D to E. So let us take point G, let us take point G here. Between D to G one resistance is there, let us draw it. And between H to G there is one more resistance. Similarly, if we go from C to F, there is one resistance, and between C to E there is one more resistance. So let us make similar point here. This is point F. Between C to F one resistance is there, and between E to F one resistance is there. And G and F, this resistance is there, so let us draw it. And between A to B one resistance is there, so let us draw that one also. Now we can see that this is R, this is R, so equivalent of these two is R upon 2. This is R, this is also R, both are connected in parallel, so equivalent is R upon 2. Similarly, this is R, so equivalent is R upon 2. That means I can replace these three resistance by single resistance having value R upon 2. So this is R upon 2, this is also R upon 2. Now, if we can see here carefully, this is R, this is R. So equivalent is R upon 2. Similarly, this is R, this is R. So equivalent is R upon 2. So here also we can replace these two resistance with single resistance. So this is R upon 2 and this is R upon 2. Now this is R. R upon 2 and R all are in series. So net resistance of these three is R upon 2 R will be equal to, this is R plus R upon 2 plus R upon 2. That means this is equal to 2R. So these three can be replaced by single resistance having the value 2R. So let us draw the diagram. So this is equal to 2R. Now these two are in parallel. So these two can be replaced by the single resistance and the value will be R upon 2 into 2R divided by R upon 2 plus 2R. That means this is R square upon 5R upon 2. That means this is 2 upon 5R. So these two can be replaced by single resistance having the value 2 upon 5R. So this is 2 upon 5R. Now these three are in series. So equivalent resistance will be, this is R upon 2 plus 2 upon 5R plus R upon 2. That means this is 7 upon 5R. That means these three can be replaced by the single resistance which is equal to 7 upon 5R. So this is 7 upon 5R. Now these two are in parallel. So equivalent resistance will be 7 upon 5R into R divided by 7 upon 5R plus R. So this is equal to 7 upon 12R. So this is the equivalent between A and B. And this is the answer. So R AB is equal to 7 upon 12R. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.